Alright guys, we're getting towards the end of our Python course. We're in Advanced Topics in Python, Introduction to Bitwise Operators, the zeros and the ones and shit like that. So apparently this is how you do the bitwise and or, XOR, I don't know. So just some stuff to keep track of, I guess. So we're going to print 0B1. You know, I had something on bits in my classes and I've always hated it. I've never found a reason to use it. I'm sure there's reasons, but just not in my case. So fill out the rest of the numbers with their corresponding binary values up to 12 in the editor to the right. So, let's see. Alright, so everything's going to start off with equals 0b. Alright, let's get a hint because I wasn't paying attention. Alright, so maybe we should have paid a little attention. Oops. So it goes 0, 8 bits, 4 bits, so 1. So I'm actually going to look at a forum real quick just to see what's going on. So alright, so let's look at this and see if we can understand it. So 1 is 0b1, 2 is 0b, so we add a 0, that makes it 2. We add a 1, that makes it 3. So 4 logically would be 0b1, 0, 0. Could. And then we just keep on switching out. So let's go ahead and Control X and see if we can get this correct. So it goes 0, B, 1, 0. Is it 1, 1, 0? Let's try 1, 1, 0. And then 6. Yeah, I don't understand this. This is why I never did very well with this. So 1, 0, 1, then we work our way up to 1, 1, 0, 1, 1, 1, 1. Alright. 1. So 5 is 1, 0, 1. Alright. So I think with 5 of these I can figure out the rest. So this equal 0b. So now this is 1, 1, 0 equal to 0b 1, 0, 1, 1, 1. Now this is equal to 1. 0b 1 0, 0, 0. This is equal to 0b 1, 0, 0, 1. This is equal to 0b 1, 0, 1, 1. This equals 0, 0b 1, 1, 1. And this is equal to 0b 1, 0, 0, 0. Is that right? Check the value for 10. So we're all the way, we're good to right here. So we have 0b 1, 0, 1, 1. So let's see what they have for 10. So we need to rotate to, oh, whoops, that makes sense. And then we fucked up our other ones in the process because of it. Forgot a 0, and we forgot to move it. So now we're good. It's kind of a pattern to it. Why it's important to know, I have no idea. So anyhow, we've tried an example of the bin function in the editor. Go ahead and use print bin to print out the binary representations from 2 to 5. So print bin. Let's try range 2 to 6. Let's see if this works. You can use a separate print statement for each number. Okay, we'll just do that. 2 print bin. Should do a loop for this, but hey, sometimes you do things the hard way. Alright, let's see here. So this is printing out the binary representation of this number. This is what like the computer sees, I believe. The console has several different ways to use the int function's second parameter. On line 7, use int to print the base 10 equivalent of the binary 1 1 0 0 1 0 0 1. So print int comma 10. Is that what they're asking? Use examples 1 to 4 as a guide. Use int to print so I'm not sure what that 2 is. Let's see if this does it. So the 2 is int 42, int 110. You might not know that this int function has an optional second parameter. When given a string containing a number, and that base number is in, the function will return the value converted to the base of 10. Okay. Shift the variable shift right to the right twice. And shift the variable shift left to the left twice. Try to guess what the print. Alright, so I've always been bad with Bitwise operators. Use example instructions. So we want to shift it. So this is our code. And we want to shift. So we'll say shift right, shift underscore right, 2, and then shift underscore left 2. I think that's what it's asking. Did you say shift right equals shift right? Oh yeah. Whoops. And of course we need to treat them as variables. Apologize if I'm not explaining this. To be fully honest, I don't fully understand it. But I mean, I'm here to learn as well. But at least you'll have a little bit of insight of what's going on than just the forums. So what's going on here is we're shifting this twice. So our OB11, we're shifting the right one to the right. So we're knocking off the last 2. And then we're shifting to the left one, and we're adding 2 on. so you can see there. Print out the result of calling bin on. Alright, so print bin of. Let's see. Is this what they want us to do? So apparently this will combine them and give us a new number, or a new result. It may not end up being a number. So for practice, print out the result using, alright, so print the bin of slash, and this above goes into a little more detail of how this works. Fully honest with you, I could care less about Bitwise Operators, so it's not exactly the most interesting thing to me, and it's just like one of those things, oh, well, you should know this as a programmer. I'm like, okay, cool. Never touched it again. Alright, so for practice, print the result of using the bracket, so print bin OB1110 bracket OB101. Try to do it on your own without using, wait. This is a 0, and this is a 0. LB1011. There you go. Alright. So, see, this is not that hard. The Bitwise Not Operator just flips all the bits into a single number. So, let's see here. Not 123 is just... So apparently this just makes it negative and minuses 1 from it, I think. Alright, so we're defining a function called check underscore bit 4 with one argument, input. I don't like that that's a prime number. It should check to see if the fourth bit from the right is on. If the bit is on, return on, not print. Check the hint to see some examples. So, if input yeah, I'm gonna have to see some examples. Check bit 4. If input it's an integer though. Oh my god, I remember this fucking creating a mask and all this sort of shit. We're going to the forums. My grade tanked after I did this. Why is mask always on? The man behind the bit mask, right? 11 and 14, alright. So let's see if we can understand what's going on here. So in this case, we need to create some. So this is, we create a mask. So in the example above, we create a random bit. We set the result equal to the input and our bit, and if it's greater than 0, return on, else return off. That's as much sense as I can make of it. I would need someone to sit down and explain this to me, to be fully honest with you. So in the editor is a variable a. Use a bit mask in the value of a in order to achieve a result where the third bit from the right a is turned on. What? Alright, in the editor of variable A, use a bit mask. So we'll say mask is equal, let's see if we can do part of this. Mask is equal to OB1. Alright. OB1. Alright. Where the third bit from the right is turned on, be sure to print your answer as a bin string. Alright, let me print bin of something. How do we check if Alright, so back to the forum on this. I know we're going to the forums a lot right now, but I think we're on 12. Turn it on. Yeah, I don't understand what to do either, buddy. Alright, so desired equals A. I guess what I'm thinking, the reason I'm having trouble, like, okay, I kind of get, like, alright, you're just saying mask is equal to a slash mask, and then you're printing it out, but okay, so somehow we're combining these two, or turning one on with our function here, so our mask has to be correct. But since I'm still struggling with trying to gather the point of bitwise operators, it's hard to find to fully understand what's going on here. Alright, in the editor is the 8-bit variable A. Use a bit mask. Alright, so we got mask and the value A. So we need a mask in order to all the bits are flipped on. Be sure to print your answer using a bin, and then we print bin, and then we have desired. We can do desired, and we'll take that guy's example, print bin, and in here we need to print desired, and we need to somehow create a mask that turns all these on. So let's start off with what we know. We know 0B, and those are all 1, 1. So maybe we do it like this: 0, 0, 0, 1, 0, 0, 0, 1. Use the caret. Make sure your answer is a binary string. I thought it did. Okay, so I thought we were doing everything right, getting them all to ones basically, but apparently we're not. So back once again to the forums. So let's see here. This answer is a little too in depth. needs to flip all the bits in A. So apparently this needs to all 3, 4, 5, 6, 7, 8 needs to be 1 to flip all of them. So I thought 1 meant on, 0 meant off, but apparently we just need to change all of them, I guess. Ugh, I have no idea. I'm sorry, guys. Def flip underscore bit. It takes the input number, comma n. This one I already can tell. No way. Flip the nth bit with the result being the first bit and storing result. And then return bin result. Alright, and then we'll say number is equal to number shift n. Is that right? Alright, so we're somewhat there. We're just a little bit off on the logic here. So last exercise. Why doesn't this work? Turn over. I just want to straight up. I don't want to get user input. B1 is less than this one. So our mask, we need the mask, and if it's less than n minus 1. Alright, let's see if we can understand this. So we create a mask again, and we know we need mask. We return the bin result, and our result is equal to the number. I don't understand why this isn't shift though. Well, anyhow, we're done with Bitwise Operators. I apologize if I wasn't much of a help, but as I'm still learning myself, and I haven't had much practice with it other than a single course. But hopefully I'll be able to help a lot more with classes. This is kind of where you really get into object-oriented programming, and you'll define classes and reuse them, and it looks like we're making a fruit class here, and we create a lemon object out of it. So I'll see you guys in the next video, and hopefully it goes a lot smoother than the Bitwise operator stuff, and sorry about the misunderstandings in there, and I wish I could be more helpful.